Good morning, everyone. I am Ragavi. Welcome to the ADTA 5560, which is the recurrent neural network with sequence data final presentation. So, in this presentation, I'm going to talk about the topics which I've covered detailedly. Let's go to our first slide, which is the content slide. So, the first topic the first topic we are trying to talk about is contribution of RNNs and LSTMs to generative AI, overview of our world in data, COVID-19 time series dataset, simple RNN model for sine wave prediction, vanishing and exploding gradient problem, LSTM solution to RNN limitation, Apple stock price prediction using LSTM, enhancement of Apple stock price prediction model using LSTM model performance, which is between the original and the redesign, and the next one is the insights and conclusion from the whole project. So the first one is contribution of RNNs and LSTM over the history of the AI. So in this, the journey of the AI from Boltzmann and distributed Markov chain to large language models were in language. We mainly explore on recurrent neural network and their advantages, particularly long short-term memories networks have played important roles in the evolution of generative AI. These technologies transitioned AI from relying on traditional models like Boltzmann machines and Markov chain, which are excellent for handling simple patterns and short sequences, to embracing more complex and capable neural architectures. So let's talk about a little more on the history, context, and the technology shift. The earlier days of the generative AI were marked by the simple statistic models that relied on understanding of probability distribution as well as transition between the states. That is like Markov models and Boltzmann machines. These were good for less complex problem or where the sequence did not go further. However, the increasing demand of for handling more complex data sets like text, video, speech, etc., it became clearer that these models cannot scale with dimensionality or remember the long-term dependencies. So next, there was the shift in the sequence modeling called RNN. So recurrent neural network was first conceptualized by David Rumhalt in 1986. RNNs brought into shift because they could theoretically remember information forever due to their looped network structure. This means that each neuron in an RNN can send information ahead as soon as the input starts streaming through the sequence. This was a big improvement from the previous models, which were stateless and treated each input independently without considering the sequence. Through the revolutionaries, RNN had some flaws. One being the inability to keep the memory over long sequence because of their vanishing and exploding gradients. So LSTM network was developed in 1997. LSTM fixed this by introducing a complex gate which controls the flow of information, hence enabling the network to maintain long-term memory. LSTM proved very efficiently for the task with history understanding. Understanding is important. Language processing or even decision-making processor where past information heavily influences future outcomes. So the next one which transformed was in the history was LSTM to transformers and large language models. Success and failure experienced by using the LSTMs on sequential data led to the development of attention machines and transformer architecture, which forms the bias of the current large languages like the GPT. Transformers differ from RNNs and LSTMs in that they don't process the data sequentially. Instead, they look the whole sequence all at once with the help of attention mechanism, which are used to determine how much importance should be given to given to the parts of the input data. This allows for much parallelism and efficiency when dealing with big data set, thus overcoming the major limitation of LSTM. So in conclusion, RNNs together with LSTM filled a crucial role in the history growth of the AI technologies. They moved the field from basic probabilities models into the advanced neural network architectures capable of learning from complex sequential data as well as generating it. This transition way more powerful. This transition is way more powerful models like transformer, which mark in the beginning of the era. So that's how the contribution of the RNNs and LNNs started. So now let's go to the second slide, and you can and here you can see the language model history, in which year they were developed. So now so in our second slide we are going to talk about the topic of time series data. Here I choose the COVID-19 data set. So the data type here of the COVID-19 is time series. Official website is from the Our World in Data, and downloadable link, you can use the GitHub repository to download, or even the website. So the time series span is daily updates from earlier 2020 to present, and its data type it has both a combination of categorical and numerical. Number of data points, so it has 247 entries representing different countries or regions. Data structure, it has 67 columns, including the case metrics such as hospital, ICU, death, vaccination rate, general health indicators, and the column overview. Is the ISO code, like the alpha 3 digits code of the continent, location, and last updated date, total new cases of COVID-19. So in this data they do have a missing data in ICU and hospital admissions columns in particular, and variability in reporting standards across countries. Additional notes we have to consider about this data is it is very essential for the public health decision and research, provides a comprehensive data for analysis and pandemic impact globally, and the derived metrics such as the cases and the deaths per million for comparative analysis. So the next topic we are going to talk about is the simple RNN. Simple RNN for a sine wave. So in this main report, it details the development of a simple recurrent neural designed to predict the future values of a sine wave. This report shows us the implementation of a RNN with TensorFlow and Keras, particularly the model ability to work on a sequential data. The construction of the dataset, model architecture, training process, and evaluation of the model performance is shown here. So now first let's talk about the introduction. The main aim of this simple RNN model with sine wave prediction project is to investigate the potential of recurrent neural networks for predicting the sequence of data. These types of networks are particularly good at dealing with time series because they can retain the information about the previous points. The sine wave as a target sequence, since it has regular periodicity, which allows testing RNN's predictive abilities without introducing complexities found in the real world time series data. So data generation, here the data consists of 1000 data points generating using the sine function over a range of 0 to 2 pi. So and data formatted into sequence of 15 data points each with the next value of the target output. So you can see the diagram here where the sine wave is generated. So you can see the x value on the horizontal line. So now let's go to the next slide and talk about the